Hello everybody, getting ready to do part 3 of 10.3 grade 6 math today. And part 3 of 10.3 generating equivalent expressions. You got 32 points here on your classwork sheet. Have that out in front of you as we go over this. And then 6 points will go into your notebook. Have that ready to go. Students, put your name, date, period here. Due date here for onliners and homeschoolers. And let's go right into today's bell work. Teachers and students, we have adding and subtracting decimals. I put a number line up here to help to visualize what's going on up here. And then down here, same thing, negative 4.79 plus negative 0.4. And then teachers, give your students about 3 minutes to do this. See you in 3 minutes. Okay, everybody, welcome back. Here's a number line here. I guess I threw in later here to visualize this. Up here, negative 0.5, which should be negative 0.5 would be about right here. And then you're going to the right here by 0.3. So you're not, wait a minute, negative 0.5 is over here. So plus 0.3, you're not quite at 0 yet. So you know that much. You're still negative here for a number, this one here. So you have negative 0.2 for the first bell work problem down here, and then negative 4.79, negative 4.79, you're sitting out here, and then you're plus a negative 0.4, so you're going further to the left here, you're going further negative here, 0.4, so you'd be about right here actually, negative 5.19 is what you would for that one. Okay, we're going to go right into our first notebook page here for 10.3 part 3. So generating equivalent expressions. So to generate equivalent expressions, you have parts of an algebraic expression, and then you have terms. So we have terms and then parts of an algebraic expression. So the parts of the expression that are separated by plus or negative signs would be one way that you would determine parts of an algebraic expression. It would be whether they're separated by positive or negative signs. So example here, 12 plus 3y squared plus 4x plus 2y squared plus 4. So each one of these this will be a term here, term, and term. They're separated by an addition sign here, or a plus sign. So these will be, there'll be 5 terms in this expression here. And then coefficients of an algebraic expressions, numbers that are multiplied by at least one variable. So 12 plus 3 would be a coefficient, 4 would be a coefficient, 2 would be a coefficient, 4 and 12 would be what are called constants. So like terms will be terms of the same variables raised to the same powers. So 3y squared and 2y squared will be like terms. And then 4x wouldn't have another like term. 12 and 4 are like terms because they're constants. So 12 plus 3y squared plus 4x plus 2y squared, these are like terms here because they have variables that are raised to the same power. So they are like terms. And then 12 and 4 would be like terms as well. When an expression contains like terms, you can use properties to combine like terms and write an equivalent expression. So when you have these like terms, you can combine them to simplify it. And simplifying is always what is asked for in writing a algebraic expression. Okay, let's get into an example. Example 3, combine like terms. So we have 6x squared minus 4x squared. So 6x squared and 4x squared are like terms because they have variables here raised to the same power. x squared and x squared here. So 6x squared minus 4x squared will be the same thing as x squared multiplied by the quantity 6 minus 4. So that would be using the distributive property here that would make this an equivalent expression to this over here. So that would be x squared times 2, which would be the same thing as 2x squared. So you subtract what's inside parentheses and you end up 2 times x squared, which is 2x squared. Commutative property of multiplication. This is your commutative property. You just move your 2 out in front is what you do here. So 6x squared minus 4x squared equals 2x squared. Okay, so now b here, 3a plus 2 times quantity b plus 5a. So what would be an equivalent expression of that? So 3 plus the quantity 2 times b plus 5a would be 3a plus 2b plus 2 times 5a. So using the distributive property here of multiplication, we distribute our 2 here to 2b and then 2 times 5a. And then when you multiply out here, you get 3a plus 2b plus 2 times 5a. 2 times 5a, this would be 2 times 5a here. So 2 times 5 would be what? 10a, right? So 3a plus 2b plus 10a. And up here we're using the associative property of multiplication, meaning 2 plus 5, so up here 2 times 5a, 2 times 5a, so 2 times 5a, 2 times 5a would be what is called the associative property of multiplication, and that yields this expression here, 3 plus 2b plus 10a, multiply 2 and 5, and then we end up with 3 plus 10a, 3 plus 10a plus 2b. So we have like terms here. We can further combine that. Commutative property of addition, we can move this closer over to here. So we can almost group this together with parentheses, but 3a plus 10a plus 2b equals 3 plus 10a, 3 plus 10 times a here. The quantity 3 plus 10 times a plus 2b. And that's again using the distributive property here. We're distributing a to 3 plus 10. Equals, what is equal here? 13a plus 2b. This yields 13a plus 2b. Okay, so 13a plus 2b, add the inside parentheses. So 3a plus 2 times quantity b plus 5a equals 13a plus 2b. 13a, 2 times a is 10a plus 3a is 13a. Plus 2 times b is 2b. So see here, y plus 11x plus 7y minus 7x. So y and 7y, so y and 7y are like terms. And then 11x and negative 7x, or rather they call 7x. So 11x and 7x are like terms. So y plus 11x plus 7y minus 7x will be the same thing as y plus 7y. We're going to move this over here next to the y. And then 11x minus 7x. We're going to move our 11x over here. And then we can do that by the commutative property here of addition. And then once we do that, so y plus 11x plus 7y minus 7x, 1 plus 7 quantity times y plus 11 minus 7 quantity times x, and that by using the distributive property there, and we end up here with 8y plus 4x. Simplify inside parentheses. So y plus 11x plus 7y minus 7x equals 8y plus 4x. And that's 10.3 Part 3, Grade 6 Math. Animated PowerPoint Math Video, AOL.com.